Hello, question 2.3, page 55. Three charges are on the y-axis. Two of the charges, each negative q, are located y equals plus negative d, and the third charge is positive 2q, is located at y equals 0. Derive an expression for the electric field at point P on the x-axis. To solve this question, we need first of all to draw for better understanding. So here's the y-axis, and here's the x-axis. The first charge is negative q on the y-axis, so the first one here is negative q, and at the same distance we have another negative q. And here at the middle, at y equals 0, we have positive 2q. The distance here is d, the same here, it's d. Now, we need to get an expression for the electric field at point B on the x-axis. So it might be on the positive x-axis or the negative x-axis. Both of them will give us the same expression, but with opposite sign. So let's take it here at this point. So here we have P. Now, we know that there will be three electric field. The first one comes from the positive 2q and another 2 from the negative q. So here is the first one, and this is the second one, and this is the third one. So we understand that the electric field here goes in this direction, and here it goes in this direction, here it goes in this direction. So first of all, we need to get each one separately, and then we add all of them together and consider that we need to get it only for the x-axis. So that means that there is no electric field on the y-axis. So let's name negative q, this one, as point 1, and here we have point 2, this one, and here we have point 3. So E1 equals negative k q over r squared. Here r is this distance, and the same like in this distance. So let's draw the triangle separately here. So here we have theta, here we have r, and this one is d. Let's call this one a. So here we have a. So that means that the distance r, according to Pythagorean theory, is equal to the square root of d squared plus a squared. So let's substitute here. So we'll get negative k q over r squared equals d squared plus a squared. Now let's get E1 on x. So E1 on x, which is, by the way, is equal to E3 on x equals E1 cosine theta. That means it will be equal to negative kq over d squared plus a squared. Now we need to get cosine theta. So here, cosine theta from this triangle equals adjacent over hypotenuse. right? So that means the adjacent here is a, and the hypotenuse is r, which is equal to the square root of d squared plus a squared. So over square root of d squared plus a squared. So let's multiply times this value, a over the square root of d squared plus a squared. Now let's simplify this. It would be equal to, let's multiply both sides, this one and this one, this one and this one. So it becomes negative k q a, and here multiplication is adding the powers. So here we have 1, and here we have power of half. So the total will be d squared plus a squared all to the power of 1.5, which is 3 over 2. So this is the first one for E1x and E3x. Now let's get E2 for point 2. Here E2, which is already on x, equals plus 2kq, because we have 2q, which is the charge, over square the distance, which is a squared. This is the second electric field that we have. Now to get the total electric field or resultant electric field on X, we should add the three electric fields. So E1x plus E2x plus E3x, which is equal to, here let's start with E2x because it's the easiest one here. So it's 2kq over a squared plus E2x is negative, so minus, as long as E2x and E3x are equal to each other, so we can say that it's negative 2EX 2 or 3. So here we have negative 2 KQA over D squared plus A squared all to the power of 3 over 2. To simplify this, to get the final expression, we can take the 2 and the K and Q as a common factor. So the remaining here becomes 2kq, then bracket 1 over a squared minus a over d squared plus a squared all to the power of 3 over 2. And by the way, this one is supposed to be positive because we already took the negative in here. And that's it. Thank you.